Hi, welcome to video 51, HSV pan sharpening in ENVI. So we're in the midst of a series of videos where we've been using radar images combined with Landsat images to try to map wetlands in the Middlebury area. So just to remind you, we have three data sources that we can use to classify wetlands. We have the radar, the Landsat, and also the elevation data. In the last video, we introduced two different workflows that we could possibly use to combine these different data sets. Workflow number one involved creating a single multi-band raster that would contain both the radar and the Landsat. And in order to do that, we had to resample the radar data to 30 meter pixels to match the Landsat. So we downgraded the resolution of the radar data, and that was video 50. The second workflow, we're going to try something else. We're going to perform an HSV fusion or an HSV pan sharpening that's going to combine the radar and the Landsat images into a single 3-band image. And you'll see one advantage of doing this is that in this case we're actually going to resample the Landsat image from 30 meters down to match the resolution of the radar image, which is 12.5. So we're going to end up with a higher resolution image. And then in both these workflows, we're going to go on to apply an elevation mask and then do the classification. So in this video, I'll briefly talk about what pan sharpening is. Then I'll explain what HSV pan sharpening is. And then I'll show how to accomplish this in ENVI. So the starting point for pan sharpening, what it means is it's pan-chromatic sharpening, and that's referring to the pan-chromatic band. And you may remember that pan-chromatic bands, they only have one band, okay? Typically it's collected in a wider wavelength interval, which allows it to be much higher resolution. So typically the pan-chromatic band will be high resolution. For example, in Landsat, it's 15 meter instead of 30 meter pixels. However, the pan-chromatic band does not contain any spectral information. Multispectral bands, there's typically more bands, and each one measures a different wavelength, so we get that good compositional information. We can construct a reflectance spectra, but the trade-off is that the pixel size is usually much worse. So you can see this is the same image, and the multispectral resolution is much lower, much blurrier. So what pan sharpening is going to do, it's going to exploit the fact that we can take the brightness from the pan-chromatic band, combine it with the spectral information of the multispec image, and get a colored image that still has spectral information but appears to be much higher resolution. So one way to do pan sharpening is to use an HSV pan sharpening. And HSV refers to a specific type of color model, and it's similar to the RGB color model, but it's a different representation. Instead of red, green, and blue, the three values are hue, saturation, and value, where hue is basically some tonal color, some chroma, that could range from yellow all the way around to pink, blue, etc. Saturation represents the distance from the inside to the outside of this cylinder. Basically represents if you start out with a pure color like green and you start to mix it with a bunch of black or gray, that would move you along this saturation line. So it's really the amount of white or black that's mixed into the color. The value is typically the brightness or the intensity, going from totally dark, so no brightness, to very bright up at the top. So those are the three terms of the HSV color model. So what HSV pan sharpening does, it does 3 steps. First, it's going to take the low resolution multispectral image and it's going to resample it down to the pan-chromatic pixel size. So in this case, we're going to go from 30 meters, the multispectral, to 12.5 for our pan-chromatic radar image. Then we're going to convert that resampled multispectral image into the HSV color scheme. So each pixel will have a hue, saturation, and value. Then for each pixel, we'll replace the value of that pixel with the brightness value of the pan-chromatic image. So in this case, we'll be replacing this with the brightness of the radar image, which we'll be using as our pan-chromatic image. So let's go ahead and have a look at this in ENVI. So here's our ENVI project. We've got our filtered radar image, that's the gamma. This is at 12.5 meters. This is a single band, okay? So it's just a gray scale of brightness in one band at 12.5 meters. In contrast, we've got our 30-meter multispectral Landsat image, which has 7 different spectral bands. So this is going to be our pan-chromatic, this is going to be our multispectral. And to do the pan-sharpening, there's a whole menu in ENVI called image sharpening. We'll open that. We'll choose HSV sharpening, and there's a bunch of other choices we're not discussing in this video, but you're welcome to try them out if you'd like. So I'll open that, and we're going to select the 3 spectral bands that we want to sharpen. Now this is an interesting choice because we're going to have to pick 3 of our 7 bands that would form an RGB color scheme, and then those are going to get converted to the HSV color scheme. So this is an important turning point in this process because we'd like to pick the 3 bands that are going to give us the best spectral difference. In other words, that are going to make the wetlands stand out the most in the image. So actually, before we pick these, let's take a quick minute and let's play around with some different RGB color combinations that seem to make the wetlands stand out. So just for your information, the wetlands are really these areas right here. So let's play around with some combinations and rejoin in a second. Okay, welcome back. I generated a few different RGB combinations. So here's the typical visible combination. Okay, here's a 4-2-1 red, green, blue combination. That gives the wetlands a nice, mostly green and red color that really does stand out from the surroundings. Here's a 5-3-2. That produced some pretty weird colors. Here's a 5-4-3. Also, I'm seeing a lot of variability within the wetland. And here's a 5-2-1. So of all these different layers, the one that I really think makes the wetlands stand out most uniquely is this 4-2-1. So I'm going to use that as my color combination to start off my HSV pan sharpening. So I'll go back to the pan sharpening, and I'm going to choose those exact bands, 4-2-1 for my R, G, and B. I'll hit OK. Now I need to pick my high resolution or my pan-chromatic file. I'm going to go ahead and pick my gamma image for that. Hit OK. Now it wants to know how I'd like to do the resampling. I'm going to choose a bilinear resampling, and I'll assign a file name. Okay, for my file name I chose HSV_421 fused, so I'll remember which RGB combination I started with, and I'll hit OK. Okay, so my pan-sharpened image has come up, and we've got some pretty wild colors, but one of the things you can see that's really nice is that vegetation that looks generally the same, okay, dark green here, looks a lot different in this pan-sharpened image. Notice how much brighter the wetlands are than most of the other vegetation. And that's because we took that bright radar return that was present in our radar image and we fused it with the 4-2-1 color representation to get a nice pan-sharpened image. Note also that if we zoom in on the pan-sharpened image, you can see the individual pixels, and you can see that indeed the pixel size is much smaller than the Landsat multispectral that it came from. So in summary, you learned what pan-sharpening is, what exactly HSV pan-sharpening is, and then how to accomplish pan-sharpening in ENVI. Please tune in for our final video of this series, where I'll show you how to generate a slope mask and apply it to the study area so that we can screen out areas that have too high slopes to actually be a wetland. Thanks.